निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा.
Thank you to one and all. May I request Honorable Vice Chancellor Sir, Registrar Sir, R.K. Shyamsundar Sir, R.K. Ghosh Sir, Professor Peter Rao Sir, to kindly take their seats on the dais. May I now request the respected Registrar Sir to kindly deliver the opening address of the inaugural conference.
Good morning, everybody. Honorable Vice Chancellor of Assam Kaziranga University, Dr. P.K. Mishra. Guest of honor and keynote speaker, Professor R.K. Shyamsundar from IIT Bombay. Guest of honor, Professor Ratan Kumar Ghosh. Distinguished and eminent professors from premier institutes across India, deans, esteemed faculty and delegates, and my dear students. I am honored to stand before you today at the inauguration of our international conference, Data Driven AI. As we embark on this journey of exploration and innovation, I am reminded of words of great physicist Albert Einstein. He once said, "The only source of knowledge is experience." Today we come together to share our experiences, to learn from one another, and to shape the future of artificial intelligence through data-driven insights. Artificial intelligence, or AI, has emerged as one of the most transformative technologies of our time, from revolutionizing industries to enhancing everyday experiences, and potential of AI is boundless. However, at the heart of this transformative power lies data, the fuel that powers intelligent systems. In today's interconnected world, data is generated at an unprecedented rate, offering us a wealth of opportunities and challenges. The significance of data-driven AI cannot be overstated. By harnessing the power of data, we can unlock new insights, drive innovation, and create solutions to some of the most pressing problems facing our society, from healthcare to finance, from transportation to education. Data-driven AI has the potential to revolutionize every aspect of our lives. The purpose of this conference is twofold. Firstly, it serves as a platform for the researchers, practitioners, and industry leaders to come together and exchange ideas, experiences, and best practices in the field of data-driven AI. Secondly, it aims to foster collaboration and partnership among stakeholders from academia, industry, to advance the state of art in AI and drive its responsible and ethical deployment. Throughout the course of the conference, we will explore a wide range of topics related to data-driven AI, including but not limited to data collection, curation and management, machine learning algorithms and techniques, applications of data-driven AI in various domains. As we engage the discussions and debates over the next 2 days, I urge each and every one of you to think critically about the impact of data-driven AI on society. Let us not only focus on technical aspect, but also consider the ethical, social, and economic implications of our work. Let us strive to ensure the benefits of AI are shared equitably and that is used to empower and uplift all the members of global community. In conclusion, on the behalf of organizing committee, I would like to express my sincere gratitude to our management, our Pro-Chancellor, Ms. Reni Kheta, and all our distinguished invited speakers, the keynote speaker, some of the Professor Srisha Rao from IIIT Bangalore, Professor Amay Karkare is from IIT Kanpur, Professor Dhruv K. Bhattacharya from Tezpur University, Professor Ashish Anand from IIT Guwahati, Professor Mausami Roy from IIT Guwahati, Professor Pratyush A.R. from IIT Delhi, Dr. Pratyajit, faculty from IIT Guwahati, and all other people who are even joining online. And I would thank all the participants who made this conference possible. I am confident that with our collective efforts, we will lead to new insights, new collaborations, and new breakthroughs that will shape the future of data-driven AI for the betterment of humanity. Thank you, one and all.
Thank you, sir, for your valuable words.
Ladies and gentlemen, please join me in extending a warm welcome to our Honorable Vice Chancellor, Dr. P.K. Mishra, on stage for delivering his opening address for this conference.
Good morning once again.
Good morning, sir.
Dr. Shyam Sundar, Dr. Bose, Dr. Srisha Rao, Dr. Karkare, our registrar, distinguished speakers, including Dr. Sajal Saha, who has been a professor of this university some time before. I am neither a student of computer science nor a professor of computer science. Neither I have any knowledge or detailed knowledge of data or AI, whatever it may be. My simple objective behind organizing this conference under the guidance of Dr. Bose, who has been an advisor to this institute, to this university for maybe last 4 or 5 years, was that a university in this part of the country should be exposed to outstanding professionals in the field of computer science and engineering. And I personally believe more than what we learn from this conference, the very presence of distinguished people like Professor Shyam Sundar or Dr. Rao or Dr. Bose or Dr. Karkare, this creates an energy in the field of education in this part of the country. And there is no better opportunity for my faculty or student friends than to interact with such distinguished people who have created a name in the field of computing science, not only in this country, but world over. Friends, what can be more exciting than have professors from IIT Kanpur, IIT Bombay, IIIT Bangalore, IIT Guwahati in Kaziranga University. It's a sheer experience which we should cherish. For some of you who do not know the background of this university, I am always excited whenever I get an opportunity to present before you the genesis of this university. Friends, this university is part of CSR activity of one of the largest industrial house of Assam and Northeast, the Khaitan Group. And it started in 2008 when a person, he was 80 years old when I met him. And he was 8th pass. He came to Jorhat 60 years before from Sikar, Rajasthan, and started his career as an accountant with a salary of 30 rupees per month. But with his sheer determination, hard work, he could create an empire of 1,000 crore turnover within 30 years' time. And when I met him through his son, Mr. Besant Khaitan, who is of my age, Mr. M.D. Khaitan, this 80-year-old person, he told me, Mishraji, whatever I have achieved, I have achieved from this Jorhat soil. And you cannot imagine, it took me 14 days and traveling through boats, through trains to reach from Sikot to this place. I don't have much education. But probably I feel there is no better way to contribute to society than establishing an educational institute. Can you help me to establish one institute? If you have an idea, what is an engineering college or what is a university, it just had this intention of establishing an educational institute. And that desire in the mind of a person who wants to contribute to the society in the form of creating an educational institute resulted in establishment of one of the best private university in this part of the country, and it started operation in 2012. So we have completed more than 10 years of our existence, and I am proud and privileged that within these 10 years of our existence, we have tried our best to contribute meaningfully to the career development of students of Assam and Northeast who were otherwise going to places like Bangalore, Chennai, Maharashtra in search of higher education. They are able to pursue quality higher education in their home state or in their neighboring state, which is a great satisfaction to all of us. Friends, I am proud to tell that this university is having students from Assam, Nagaland, Arunachal Pradesh, and probably all the 8 northeast states. And many students from this university are pursuing higher studies in United States and Europe. And many students have joined top corporates, including KPMG, Ernst & Young, Deloitte, and PricewaterhouseCoopers. So it's not a mean achievement, but after completing 10 years of our existence, probably the next 20 years will be to try for excellence. And I am thankful again to the distinguished guests today who have come from all over India and from top academic institutes in the country, that their very presence, their guidance will see that Kaziranga University emerges as one of the best private universities in this part of the country in the next 10 to 20 years. Thank you very much, and I welcome all of you once again.
Thank you so much, sir.
Ladies and gentlemen, now it is indeed a privilege that we have with us today Professor R.K. Shyamsundar, the chief guest for today's inaugural ceremony. So he's also going to deliver the keynote address. But before I invite Sir on stage to deliver the keynote address, let us all brief you all about Sir.
Dr. R.K. Shyamsundar, sir, is a Life Fellow of IEEE, a Fellow of ACM, Distinguished ACM Speaker, Distinguished Alumnus of the Indian Institute of Science. He has served as the IEEE Distinguished Speaker and was the founding Dean of School of Technology and Computer Science at the Tata Institute of Fundamental Research. He has been a J.C. Bose National Fellow at TIFR and IIT Bombay, and he is an INAE Distinguished Professor at the Department of Computer Science, IIT Bombay. He is an Adjunct Professor at NITIE Mumbai. He directs Information Security Research and Development Center, sponsored from the Ministry of Electronics and Information Technology in the Government of India, and the Center of Excellence in Blockchains sponsored by Ripple at IIT Bombay. Sir was awarded the 2014 SM Mitra Award for Excellence in Research by the Indian National Academy of Engineering. Since 2015, he holds the distinguished position of Scholars in Residence at IIT Jodhpur and is a distinguished fellow at the Institute of Development and Research for Banking Technology. He has more than 300 peer-reviewed publications in journals and proceedings, 8 patents, 8 books, and guided more than 40 PhD students. He has been a visiting faculty at UIUC, UCSD at Lajola, IBM Research, Max Planck Institute, JAIST, University of Linköping. He had also been an adjunct faculty at School of Computing at NUS Singapore. He had been invited faculty at Technological University of St. Petersburg, Russia, and distinguished fellow of the UK Royal Academy of Engineering at the Computer Group, University of Cambridge, as well as the City University of London. He has also been recently honored with a fellowship from the British Blockchain Association. Sir is a fellow of the Indian Academy of Sciences, Indian National Science Academy, National Academy of Sciences, National Academy of Engineering, India, and a fellow of the Academy of Sciences of the Developing World at Trieste, Italy. He serves on the IEEE Fellow Selection Committee on Product Safety. He is also a recipient of the Diamond Jubilee Medal from IETE and also its fellow member. Currently, he is also chair of the IEEE Computer Society section of Mumbai region. He has been at the governing council of IIIT Allahabad, Indian Institute of Information Technology and Design Manufacturing at Jabalpur, CSIR Fourth Paradigm Institute at Bangalore. He serves on various DST, MEITY, SERB, UGC, AICTE committees and has been serving as WG member for cybersecurity at the Ministry of Electronics and Information Technology, Government of India. He also serves on the research advisory boards of DSE member for DSE and IBRBT and serves on the Board of Studies in Computer Science from various universities. He has served on IEEE Estoril Standards Committee. He is serving as Editor-in-Chief for Sadhana Journal of Engineering Sciences of the Indian Academy of Sciences for Computing and Data Sciences, Subject Area Editor for IET Blockchain Journal, and he serves on the editorial board of Journal for Parallel and Distributed Computing and Journal of Banking and Financial Technology.
Thank you, sir, for gracing us with your valuable presence today. We'd like to felicitate sir with the Pradhan Sir and the memento. May I request Honorable Vice Chancellor sir to kindly felicitate our chief guest of the occasion, Dr. Sir. Ladies and gentlemen, can we have a round of applause for our guest? May I now take the privilege to welcome you, sir, to deliver the keynote address.
No, I'm not connected. But Good morning. First, let me thank the conference organizers for giving me the opportunity to address, and also the Honorable Vice Chancellor, Professor Mishra, who has been very kind and a great host for me. So thank you, and my all the other friends. So I think we are delayed by 15 minutes, but I'll just say 15 minutes or there kind of a thing done. So I think it was nice to hear from Dr. Mishra that you have been working as one of the leading universities in this region for this year. And also this is also a right occasion because with the starting of the electronic foundry, and this is also the right time to see how you have to re-look and then see how the importance of innovation should be taken into account in the Kaziringa University to cater to the needs of the region as well as the nation kind of a thing. And this electronic foundry is supposed to become the supply chain for the world. So in some sense, it is for the region, India and the world as well kind of a thing. I wish him all the best because he has brought a university to this level in 10 years. Normally, even when I was in TAFR, if you want to set up a center, it takes nearly a year. Setting up a university of this order in 10 years is not a simple task, and that too in this region. I wish him all the best kind of a thing. Now I have two things. One is I have to give it as a chief guest, and also I have to give a keynote. So and also earlier I was supposed to be even on a panel. So I requested Barbana to say that I should be excused from the panel because whatever I say in a chief guest, I may have to repeat it in the panel. I'm happy that she accepted. See, this artificial intelligence, we cannot start without remembering Alan Turing. He is a founder of the computer science, and the world celebrated his centenary in 2012. So in the context of the celebration of the centenary, the editorial of Nature, one of the very established publications, they said it's the finest, describing him, they said, finest types of intelligence, human, artificial, and military. So all these they included. Turing is perhaps the only person to have made a world-changing contribution to all these three things are there. So to begin with, Turing, the intelligence came, he coined through the notion of a Turing test, which was just an imitation game. There was a judge, a man and a woman. All chat via Zoom, via email. Man pretends to be a woman, and the man lies. Woman tries to help the judge. Judge must identify man after 5 minutes. And so the Turing test is replace man or woman with a computer and fool the judge 30% of the time. This is the current same. I'm not going into the what is the current status of the Turing test and how it impacts, though by itself it does not have a very significant thing, but the earlier notion, the way people tried, has a big impact. And so somebody asked him to define what is intelligence. So if a machine is, he said in an address to the London Mathematical Society way back in February 1947, if a man is expected to be infallible, it cannot also be intelligent. So we can always now take a pat on the chat GPT or the Bard or anything. Whenever we don't like the answer, what it gives, it's after all, it's also a human kind of a thing. So now, coming to this AI, you can see two kinds of things. One is an engineering activity. If you look at the current trend when you say AI, it is essentially a complete engineering activity what you see. And Now here, the broad goal, if you look back in those days, design a working AI system that exhibits some well-defined agentive behavior without worrying about homology between artificial system and the natural system. The question would be, does it capture the essence of machine learning as used for commercial mining of the data? And the next thing what you could ask is, John McCarthy is also the real founder of coining the word artificial intelligence. He designed the language Lisp. Earlier, AI was equated to the usage of Lisp and applications of Lisp. The pattern progress in the field has been rapid, followed by years of more sober and very incremental measures. So now rapid progress was possible later in the use of AI and ML with the large-scale implementation of the seminal result on backpropagation proposed in 1986 by Hinton in 2012. Hinton's result, what he gave us in 1986, but it came into prominence in 2012 because technology was there to see how one could experiment. For example, it was the cheap technology like GPUs, where now NVIDIA is one of the leaders of the AI. Large collection of data, several corporations and governments have collected huge data for commercial exploitation. So now if you look at it, all corporations have made huge impact. IBM has made a periodic breakthroughs through Deep Blue, beating chess champion Gary Kasparov. So this was Deep Blue, and it's one of the major things at this point, kind of a thing or the other. When the Gary Kasparov was defeated by the IBM Deep Blue, John McCarthy was still alive, and he lamented when Deep Blue met Gary Kasparov. He said it killed the Drosophila of research. Chess was considered the Drosophila of research, and by doing a data intensive thing, it was able to conquer Gary Kasparov. Gary Kasparov also has written a book later, and so now he lives, as you know, you must have read in the newspapers that he is no longer in the USSR and he lives in US. So IBM has made, as I mentioned, one of the breakthroughs, and then the Watson, which was a later version of the Deep Blue, bet Jeopardy champion. That's a thing that happens in the US. This one, and now the missed debater is still to conquer the champion, that is the Watson. So now here, if you look at what is the current scenario coming into the picture, and now if you see that here, 2012, it was a big impact on the AI. And now actually it has to slow down. If you look from the fundamental results point of view, you may not be able to find a large number of results out here. So now let me just say what is the current scenario. Giant corporations like IBM, Google, Microsoft have demonstrated AI and ML through game-playing machines like chess and Go. Go is something which is supposed to be, you may be able to counter chess, but Go is something was a challenge, and then Google and Microsoft were able to do that, and you have a big thing in the natural language translation, speech recognition, etc. One of the characteristics of this technology has been the capability of collecting huge data for training. So now you have the big thing, the large language models, and you have the BARD, and you have the ChatGPT, and the varieties of things that come into the picture. However, if you look at it, there are situations like thin data sets, weather, shadows, traffic, on which decisions need to be made. So the question at this point in all these things is a human better taking a decision, or machine keeping in view the Turing's view that if a machine is expected to be infallible, it cannot also be intelligent. Now the question, for example, if you see the driverless cars, which has become a reality, does autonomous vehicles and driverless cars come in the above category of these data sets? So now if you look back, Gary Kasparov has written a book called Deep Thinking. He says what is now the deep thinking where machine intelligence ends and the human creativity begins. See here, you can see what is the analogy that he brings. It's a very nice book. He articulates the way the deep blue defeated him and what was the thing that was able to defeat and etc. etc. I'm not going to read. So now if you look at it, machine learning is a black box. Fuzziness of the inference process makes it difficult to justify using machine learning program output as determinate result. Is this a serious limitation? So this is a question. And if you look at some of the points, what one has gone in when AI was developed, even in the earlier century, Hans Moravec calls it a paradox in 1988. He says at that point, at that time there was no immediate technology and it is comparatively easy to make computer exhibit adult level performance on intelligence tests. Or playing checkers is difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. It seems it looks like they took a champion, like a chess champion, and then made him play with a 2-year-old or 3-year-old, and he got defeated in some checkers. And that's where he says, creating what a 1-year-old or a 2-year-old does is something which is not an easy thing to do that or capture. Machine learning has been used extensively in some sense, which is an extension of the earlier computational thinking that was proposed and which has been the hallmark of many of the science disciplines now, used in sciences and has yielded success, including chemistry, for which your Vice Chancellor is a chemistry PhD. So chemistry is the one which used a lot of computational thinking to get scaling up results, and astronomy is another one. Whatever you give them, it is not enough because the universe is so big, it's extremely difficult to do that kind of a thing or the other. So now the question is that practical, how would you compare the success in these areas as opposed to commercial and societal usage? And so now most of practical successes of machine learning, they rely upon algorithms that lack guarantees of running time or quality of the solution. In fact, this is one of the main aspects that is highlighted by one of the leading researchers, Sanjeev Arora from Princeton, which I'll just touch upon later in my talk. So is this an issue for the user, or is this one of the challenges for the computer science team? Now, if you look at AI as science, is concerned with psychologically viable computational modeling of agentive behavior. An agent is characterized by an action repertoire which it can deploy intentionally to bring about desired for changes in the world, including itself. Systematic study of agentive behavior then involves articulating computational architectures and computational processes relating to one or more of the several aspects of the agents. True artificial intelligence will require more science of understanding of the processes of animal and human life. There have been efforts like computer modeling, brain in a box. For example, if you look at Henry Markram, mapping synaptic input fields of neurons with super resolution imaging. And it is not, it is always good to, forecasters are always important. There was a great forecaster, Ray Kurzweil. Artificial intelligence will not displace humans, it is going to enhance us. This is the same thing when people tried about IT or computer science, that it will displace work, and this is the thing he says. More intelligent AI will also make us smarter. So that is what I think. Whatever you are, you should become more smarter to say that I am going to beat it kind of thing. So now here it is good to recapture. Again, Alan Turing also was a forecaster, and he had forecasted so neatly, it's as good as a God kind of a thing. The original question, he says, can machines think? Believed to be too meaningless to deserve discussion. Nevertheless, I believe that at the end of the century, the use of words and the general educated opinion will have altered so much that it will be able to speak of machines thinking without expecting to be contradicted. So it becomes so ubiquitous, so it is, the question is that. Now where are we and what are our questions is something which I am sure the panel will be able to discuss. So now the question is that one of the main questions is concepts. Can AI demonstrate creativity? So that is one of the main questions from a scientific perspective one is answering, which also mentioned earlier. The notion of intelligence, what we have tried to say, intelligence and creativity, it will be a catalyst for creativity. It is just like if you ask whether I can bring out AI can bring a Euclid's theorem or something like that. That's a question what one has to worry about kind of it. And now, like I think this is also a point I see is going to be discussed. Now, what is the current explainable AI not meeting the expectations? XAI, which is also called explainable AI, seeking better explanations for how algorithmic decisions are made. One of the Google scientists in 2018, he made this suggestion in one of the World Congress, which better inspires how trust can be. Say, for example, you have, let us say, a spaceship P1 and a spaceship P2. Spaceship P1 has been completely, you have given complete rules and how it works, etc. And you have a spaceship P2 which has been tested and it works and you know that it works. Now the question would be whether you would trust P1 or P2. In fact, one of my colleagues from France once asked me, you know, we are doing so much model checking. Would you like to sit on a plane on which they say your model checking is the one which said that this flight control is correct? Then he said, no, I will not sit on the one what I'm going to be sitting kind of a thing. So the trust, now here is the thing, science, explainability and all these things come into the picture. It's a very, very strong kind of a thing or the other. And one of the main problems in the context of explainable AI is one size does not fit all. Because we have computer scientists, we have chemists, you have physicists, and so on and so forth, and also the general public. The view is totally different. What you explain to a computer science is not the same as what you can explain to a physicist kind of a thing or the other. So these are all some of the issues. And another one, now for example, if you see Australia and India introduce many joint projects on what is called AI and ethics. So now can AI demonstrate creative, can ethicists really work on this kind? There are two problems in this context. Either one can be inside a big corporation or you can be an outside corporation or an activist. As you know, one of the whistleblowers from Google said something and then she had to quit and she started her own institution kind of a thing or the other. So in some sense, you see that there is a big difference. And the last two things with which I will wind my chief guest address is inherent limitations of artificial intelligence fairness. Fairness I will touch upon in my talk. And then finally, and this is also I think important aspect which I think the panel will discuss, I understand, computing education in the era of generative AI. With this, I think you are going to have a nice panel discussions with several experts, with several things. And one of the things people have to see is that AI is no longer the domain of computer science. There are more non-computer science people working on what is called AI, and then what is the way you do that. But when the computer science view it, it is a something completely different. We may not consider it whether it is deterministic, whether it is non-deterministic, whether it is probabilistic. And this kind of a quantitative way we are going to measure kind of a thing. So it will be an exciting area, and also in the context of technology. And it is not just technology, ethics, humanity, and many things have to come together if it has to succeed. And towards that, I would imagine the university also can take a lead in trying to see how these things can be integrated in the curriculum in all the departments kind of a thing or the other. For example, music, whether the composing music, certainly there are many things on which we can compose many things or the other. Whether it will create the 65th raga, I have no idea what is the thing or the other, kind of a thing or the other. But certainly, like many films have been made and many nonsensical things have been made, but all of them, an intelligent person in any area can use it to the best advantage of this one. And the other coin is can also be a destructive way in many ways or the other. So with that, I will conclude my chief guest talk, and then I will start the other. Thank you. Which one you have here? HDMI or HDMI? So now at least the immediate intelligence is working, so it connected quickly, which is not usually the case. So I think technology has improved a lot, kind of thing. You cannot see that it should automatically come, but we have not embedded that. Thank you. Now I am having a different hat, so you can interrupt me and then ask me questions at any point. As a chief guest, you are not supposed to ask anything, but the same questions you can ask me during this time. Thank you. So now here I am just going to give a overview. I may not go into the underlying mathematical details because I am assuming there is a large number of undergraduates, and so I think some of my senior professors should excuse me if I am going to be too naive at many of these aspects are here. So here, so this data organization, let us not worry about. So now here, if you look at learning, can you see people at the last, can they see this?
Yes.
Hello? I think, is it good afternoon or good morning? So, right. So, can you see this? And so here, if you see what is learning a language, concepts, phenomenon of knowledge acquisition in the absence of explicit programming, and a methodology for the study of phenomenon from a computational perspective. Skills that consist of recognizing whether a concept or a predicate is true or not for a given data. A concept C has been learned if it has been deduced. This is one of the ways in which you can say, if you look at a very simple way, the concept of learning setting, imagine learning an algorithm trying to decide which loan applicants are bad credit risks. This is one of the major things you go on getting emails nowadays. Might represent each person by n features, his income, range, debt, load, employment history, etc. kind of a thing or the other. Take sample yes of data, labeled according to whether there were or weren't good risks. See, that's what you are going to do. And the goal of algorithm is to use data seen so far, produce good production rule, that is a hypothesis H of X for future data. For example, to give a very simple example, so the concept learning setting, you are given a setting and you have what is percentage down, recent delinquent, etc. Given this data, some reasonable rules might be predict yes if not recent delinquent and 10% down is greater than 5. Similarly, predict yes and if 100 times, etc. kind of a thing. So this is what you would hypothesize. Now the question would be, how might we automatically generate rules that do well on observed data? What kind of confidence do we have they will do well in the future? So that is the main question that comes into the picture. What is to be optimized? That's a question of sample complexity, how much sample you should read, and also you have the classic grammatical inference problem. You also give it positive samples as well as negative samples. That means that it has to be there and it has not to be there kind of a thing or the other. How to optimize it, and that is the algorithmic approach or the other. And the power of the basic paradigm is, there are lots of problems solved by converting to basic concept learning from structured data setting. For example, if you see the document classification, you are going to convert it to bag of words. And driving a car, convert the image into features. And use neural net with several outputs are here. So now, for example, in the list example, what I said, how can we find a consistent deal? So now, for example, if I have 5 parameters and the labels that have been given as plus, minus, etc., what is the way I can decide, or how does the algorithm decide the rule? Now you can say, if x1 is equal to 0, then the answer should be minus. So I delete those 2 rows. Now here, now if you say x2 is equal to 1, then the answer is plus, I delete that row kind of a thing. And similarly, I continue it for all the parameters till all the rows get exhausted. And so the decision list algorithm, which is the basic thing, and in fact, in one of the recent communications of ACM, there has been a good discussion on these decision list algorithms as well kind of a thing. Start with the empty list, find it, then rule consistent with the data and satisfied by at least one example. So, worst come, you may have to say everything or the other. Put rule at the bottom of the list so far and cross off examples that are covered and repeat until no examples remain. And if the algorithm fails, then you say there is no decision list consistent with remaining data, and so no DL consistent with the original data kind of a thing. Okay, fine. Now, why should we expect it to do well on future data? That is the main question. That's where we enter the machine learning, which is a new kind of science. Sanjeev Arora, he is one of a very distinguished computer scientist. He is also one of the winners of the American mathematical prizes. This one, science of creating machines or programs that improve from experience and interaction. So that is what he is saying. Imitating human intelligence is not an explicit goal. You see, this is where you have to make a distinction between AI and the classic machine learning, what we most of the times are using it kind of a thing or the other. So now here, the question we have to understand is, what is learning? What does it mean to understand the world? Describe a scene with a pedestrian with a sequence of pixels. So now learning patterns in data becomes the question of learning. So now machine learning, here you have a set of methods that can automatically detect patterns of data and then use uncovered patterns to predict the future data, or to perform other kinds of decision making under uncertainty. For example, here detecting patterns, so repeated periods of fluctuation. And yesterday, I think Professor Rao was highlighting about Roman civilization, etc., kind of a thing or the other. And so now, what is the way that can be fitted later? General trend is that temperatures are rising. So now here, what you would say is that how the annual average, 5-year average, how they are all increasing it kind of a thing. Now, how do you specify the patterns? Build a model for the patterns with a function. Let us say it's a polynomial. Model is not accurate for individual years. Overall captures the major trend. If you look at it in the curve, the one what it goes in between, that is the one what you are going to say whether it is monotonically increasing or decreasing, the kind of a thing or the other, or remaining the same or the other. Similarly, questions one can ask is, predicting the future, polynomial model not exactly accurate for a specific year, but I think it is pretty close to what I think what you need, because you don't need an exact answer for many of those things or the other. So learning from the example, so key ingredients in the machine learning task, the data collected from past observation, which is the training data, and the model devised to capture the patterns in the data. The model doesn't have to be accurate. As long as it is close, it is useful. We should tolerate randomness and mistakes and outliers, etc. Several interesting things are stochastic by nature. Prediction, apply the model to forecast what is going to happen in future. So we'll not look at computational learning. This is another aspect that has been done by one of the Turing Award winners, less variant kind of a thing or the other. Now, why is it that the machine learning has been popular? Data, there is a flood of data from various sensors, leads to several high impact applications, for example, cell phones, internet applications, scientific studies, and so on and so forth. Computing, powerful and cheaply available computing resources enables efficient storage, processing, and analysis of data. Cloud computing, GPUs, cell phones, and so on and so forth. You have a spectrum of applications like speech recognition, information retrieval, and search, email, document classification, and highly desirable expertise from the industry like Google, Facebook, Microsoft, Yahoo, and so on and so forth. And the applications are enormous. Biology and genetics, identify disease-causing genes and genes network. Climate science, predicting global warming trends. Social science, social network analysis, social media analysis, where we can remember what happened to Cambridge Analytica and Facebook. Business and finance, marketing, operation research, and healthcare and energy is one of the things. For this, we have a rich history of applying statistical learning methods. If you look at R. Fisher, one of the great statisticians, what is that in the flowers, you have types of iris, which is setosa, versicolor, and virginica. That is the three different things. Can you identify from those things or the other? Huge success 20 years ago, recognizing handwritten zip codes, for example, AT&T Lab kind of a thing or the other, which was nice from a perspective of trying to identify the postal code. So this was one of the great applications where you can do the automation of sorting kind of a thing or the other. More modern ones is recognizing your friends on Facebook. and then you can say, oh, this man was the person who was missing, and many other aspects are there. And learn your preferences, which is one of the great things that come into the picture, like the Netflix. What is the recommendation, what you might like, which you have seen this picture, or which you have tasted this one, etc. kind of a thing or the other. So machine learning has varieties. Supervised learning make prediction given label training observation, for example, spam detection, iris. Unsupervised learning discover hidden and latent patterns in data, data exploration, for example, topic modeling in text data. Topic modeling is something, for example, if you take a New York Times, and now you can say, what are how many times the Obama appears, what is the important thing or the other, what are the important topics for today, etc. kind of a thing or the other, for which it uses a good mathematical matrix models kind of a thing. Reinforcement learning act optimally or at least well under uncertainty, for example, defining robots' behavior with the world based on the feedback, for example, rewards and punishments it receives from each action, and deep learning and other paradigms. Again, you have to distinguish from the Bayesian computational learning, which is fact, that is probability approximate kind of a thing on here. So now if you look at the mathematical formulation, machine learning, you can see it as if it is a old idea of curve fitting, go back to 1800, Legendre and Ross. So now here you see that on this one you have, sorry. So in the left-hand side, you see that inflation and unemployment, this gives the curve, and then this is the classic gas law, PV is equal to NR. Machine learning uses surface fitting with many more variables, for example, 20 million. So learning patterns in data. So now here, you have simple algorithmic approaches. So let me just highlight, because then I think you will get a feel for what is the thing that is happening or the other. I'm just going to take a simple example of a k nearest neighbor or the other. Again, looking back at the recognizing the flowers, whether it is Setosa, versicolor, or virginica, and so measuring the properties of the flower. Features are the widths, the lengths of sepal, and the petal. So now here you see that this is one data, you have 4 features, and you can make it into 3 classes kind of a thing or the other. Pairwise scatter the plots of 131 flower specimens, and visualization of data helps to identify the right learning model to use, and each colored point is a flower specimen. For example, if you look at these things or the other, the red ones, the green ones, and the blue ones, kind of a thing or the other. So different types seem well clustered and separable using 2 features, which is essentially petal width and sepal length. So based upon the data, now you can say classify them into 3, what is the way, it reducing from the many features are here. So it's a multi-class classification, classify data into one of the multiple categories. Special case, of course, is a binary classification or the other. And what is the thing that you require? You require a training data, and then the test evaluation data, and now you have a notion of a spectral clustering. An important part of a clustering toolkit when data lies in RD is a singular value decomposition, and spectral clustering is another aspect that comes into the picture. In the context of k-means clustering, assume that data points lie in a real RD and focus on the k-means criterion. And suppose we have already determined the clustering or the partitioning into C1 to Ck, best centers for the clusters. Let us say A1, A2, An be a set of points. Sum of the square distances of A into any point in the X is given by this modulus, which the formula, which I think all of you may know it. And there is the famous Lloyd's algorithm, which says that you start with k centers, cluster each point with the center nearest to it, find the centroid of each cluster, and replace the set of 4 centers with the centroids, and repeat the above two steps until the centers converge according to some criterion, and such as the K means a score no longer improving kind of a thing. So that means that you have essentially from the samples been able to do that, and this is the nearest neighbor classification. And if you look at the visual example, in this two-dimensional example, the nearest point to X is a red trailing instance, thus X will be labeled as red. So classify iris into two features, and now you have petal width and sepal length, and based upon which I have classified them into three categories. And similarly, you have how to measure nearness with other distances. And now, where is the decision boundary? For example, if you see it is not a linear one, for every point in the space, we can determine its label using the nearest neighbor criterion rule. This gives rise to a decision boundary that partitions the space into different regions. So now here, this is the K nearest neighbor classification, how to classify, etc. Let us not. And so here you have a K equal to 1 red, and here you have K equal to 3, that is the nearest is K, and then it becomes red, and then blue kind of a thing or the other. Now the question is, how to choose an optimal K? When K increases, the decision boundary becomes smooth. So that is the question. If I had earlier rough this one, as I increase K, it becomes a smooth kind of a thing. What is the advantage of the nearest neighbor cluster? What is the takeaway? It is that computationally simple, easy to implement, just compute the distances. Has a strong theoretical guarantees that it is doing the right thing. Disadvantages are computationally intensive for large-scale problems because it is of the order of ND. For labeling a data point, we need to carry the training data around. So this is the main problem that comes into the picture, and this type of method is called non-parametric, and choosing the right distance measure and K can be involved kind of a thing. So let us not go into some of the details or the other. And now here you can have something like, can we cross-validate what you have actually done it. Another practical issue is distances depend upon the units of the features or the other, and now this can be overcome by doing some kind of a pre-processing kind of a thing or the other. And what is our learning in this simple example? It's a simple learning algorithm, issues to be considered for good accuracy kind of a thing. Similarly, you have the tree model which has some advantages. I will not go into some of those details, and let me proceed further. So now, if you say learning to score the reviews. So for example, if I say it's a slow moving, couldn't get into this movie despite all the awards it has won, like if you see many of the Oscar movies, and now you say that this is the sentence what one has used, and then if it is a score is 2.5, and now wow, we couldn't know what to expect and was delighted and loved the homage paid to the musicals of the world. Like yesterday what we said. What is the thing that comes into the picture or the other, whereas the first one was minus 1.5, the second one was 2.5, given reviews for different movies and rating scores ranging from -3 to +3, task is learn to predict rating score given text of a new review, the law of movie review scores. So now here, learning to rate reviews, slow moving, couldn't get into this movie despite all the awards it has won, so that is the sentence. Now you have, let us say, 100,000 words in the English dictionary. Hypothesized law, which is a simple linear model, each word has a sentiment score. Review score is the total sentiment score of all words in it, and finding sentiment score for 100,000 words equals surface fitting with 100,000 variables. You see the problem that comes into the picture if you want to do this. And so now here, if you have 100,000 words in the English dictionary, And if you are going to hypothesize the law, each word has a sentiment score. Review rating equals total sentiment score of all the words in it, kind of a thing. So algorithm is Gaussian least square fit, solvable in seconds, given few million rank reviews are there. So now here, if you look at the hypothesized law, like if you say the same as an example, each word has a sentiment score, what I have said. For example, here you have word and then the score is plus 0.1, good, plus 0.6, home is 0.0, and the total score, total sentiment score of all the words in it, kind of a thing are together. And now you say that if you add discovered patterns equals how words correlate with the positive score. So the machine learning finding suitable function model given examples of desired input and output. For example, you have a training parameters, and then you have the review text, and then this is the training method, and now it is the desired output, and this is the model output, and this is the output that comes in the training model, and then you are going to increase the training data and then see what is the way that is going to come into the framework. So now the formal framework for this has been inherited from the classical statistics. Assumption is the samples drawn from a probability distribution D, distribution on pairs of movie review and rating score. Training is optimize the loss that comes into the picture. Loss could be obtained as from all these things and what is the actual review, and then you are going to get the testing. In practice, train on 80% of the data and test by evaluating loss on remaining 20%. So if you are given 100 samples, you train them on 80 and then see what is the loss that you are going to have on the remaining 20 or the other assumptions. Drawn from probability distribution, Fourier analysis allows learning if from x of x under reasonable assumption F, but practically infeasible if x belong to the n real number. Samples can also computational time or the other. In practice, if n equal to 10 power 4, the number of samples is again 10 into n kind of a thing or the other. So training by a gradient descent, this is the natural algorithm. You have this trainable parameters starting with some theta 0, compute for t equal to 0, 1, 2, and then you are going to get from an iterative manner the t plus 1 obtained by tt plus the noise level kind of a thing, or the what is the loss, and often it is non-convex, it is not convex, so it becomes this is convex, and if you see it's a non-convex. And now here you say in practice the gradient descent with the tricks, time varying eta, past gradients, regularization kind of a thing are here. Now coming to the deep learning, you have input, you have a matrix M1, you have M1, X1, you have non-linearity, and you have introduced X2, X3, and so on and so forth are the other. And non-linearity is given a vector, output some vector, but negative entries come into 0, and you are having the training data. How to compute the gradient of loss? Back propagation, that is where the neural networks and all these things play a vital role. Algorithm does it fast. Clever application of chain rule coming into the picture, and then you have a non-linear enough to express many things, linear enough to allow quick optimization on today's computers kind of a thing. So now here, if you look at the aspect, the review rating was total sentiment score. What we observed was the sum of all the metrics that was associated with the word, and now this is not how we humans do it. Word order in text matters, no good versus good, no. So now don't need millions of examples because we understand language. So now here, because we understand language, science has long tried to understand and formalize language, plus semantics using logic, grammars, model theory. How can machines understand language, arguably more general purpose than rating reviews? Unsupervised learning means no human supplied labels,
Key idea: using large corpus like Wikimedia, train model to predict part of text from adjacent text. Example, I went to a cafe and ordered, and then you can say that from this, what would it mean? Model learns to do such completions by training on huge amounts of text, and that's what is being done in many of the large language models. In the process, implicitly picks up on a grammar rules, common sense, etc. kind of a thing or the other, used in machine translation, question answering. If you go to the Panini's grammar, you see that how the selection is made and whatever the thing or the other, and these are all aspects that need to be worried about a kind of a thing or the other. Now coming back to predicting review scores, passively understanding the word meaning, how can machines actively interact with the world by a sequence of intelligent decisions? And 20th century antecedents, probability theory, you have betting, gambling games, for example, martingales, the probability theory, economics, managing stock portfolios, playing repeated games, control theory for power plants and machines. So now, why no overfitting even for models with the 20 million parameters trained on 50K samples? Popular conjecture: when trained on realistic data, the next parameters are constrained by problem and or training to be highly interdependent, for example, lie on manifold of much lower dimensions, even though it has 20 million. So properly trained nets have noise stability property. This implies their parameters lie in a lower dimensional subspace. So now here, coming to the notion of role or bias. So machine learning decisions, is there a bias? Is it fair? And this has something which has been done by Cynthia Dwark, the person who has started the differential privacy. Decisions are driven by data. Decision maker's goal is to maximize accuracy subjected to the given constraints. Which TV should I buy? Which car? Etc. You could be the object of decisions. What movies will be recommended to you? What medicines will be given to you? Classifying people based on decision derived from data. Are you credit worthy? Are you college ready? Would a person have the symptoms of recidivism? So what is our comprehension of the machine learning? Is it just a statistics? Statistics bias, a difference between estimator's expected value and the true value, and what is the focus? Is it prediction, or prediction versus explanation, or is it engineering? So you have a supervised classification, for example, training data, points with the features X and a label Y. Goal is to find a rule to predict label Y from feature X of the new data. So now here, can we predict future using the derived rules? So now, what does not work? Decision rule that exactly fits training data, this overfits. We haven't learned, only memorized. We wouldn't know how to generalize, that is, classify a person whose data is different. To learn, we must summarize or simplify. For example, here, if you look at this, how you are going to classify them or here. This introduces errors, and now what is the way to simplify? You have starting from linear functions, small decision trees kind of a thing or the other. Why do we think that there is a bias? Data might encode existing biases. Labels are not committed a crime but was arrested. Data collection feedback loops only observe paid back loan if the loan was granted. Different populations with different properties, SAT score might correlate with label differently in populations that employ SAT tutors. Less data about minority populations are the other. For example, Amazon's automated hiring tool discriminated against women because that data was not there, women were not employed. And so they abandoned that approach kind of a thing, itself kind of a thing. So data collection and the feedback. For example, only observe paid back loan if the loan was granted. But if the loan itself was not granted, there was nothing like the loan has been paid. So it is just like a credit card. Go on getting the loan and going on paying it, and then you become more and more credit worthy, and then you get more credit kind of a thing. That's how some of the populations which never got a loan were never in the database, and so they were completely omitted, even though at some point they were much, much better off kind of a thing or the other. The upshot is, to be fair, the algorithm may need to be explicitly taken into account group membership, else optimizing accuracy with the majority population. And the upshot is, algorithms trained on minority populations will be less accurate, qualified individuals will be denied at a higher rate kind of a thing. How do we go forward? So precisely define what we want to solve, then worry about how to solve it efficiently, if possible solve it exactly, if not solve it approximately, but with provable guarantees. So need precise definitions of fairness goals and other goals. So now here, if you look at fairness, now here gender was misidentified in 35% of darker-skinned females in a set of 271 photos. Again, the lack of data kind of a thing there. So role of bias is identify and mitigate bias in a machine learning based decision making in all aspects of data pipeline. For example, you have an example of a bias. You have Pascal cars, Sun cars, Caltech 101 cars, ImageNet cars, and predictors trained on Caltech 101 cars won't recognize the sports cars, because sports cars won't go on the 101, they go on a real freeways kind of a thing or the other. Similarly, translation. So now from Hebrew to say to English, if you can just say this translation or the other, whereas the inverse translation, people say even now, if you look at many of those, don't try it kind of a thing or the other. And so now that is what would be a kind of a thing or the other. So for example, here you see that he is a nurse, she is an engineer, and now it would say she is a nurse and he is an engineer, and all this kind of a thing comes into the picture. So data biases are inevitable. Real challenge is how to make algorithm or decision support system support human values. How do we realize fairness? Model centered on add fairness criteria to the objective function, regularizer, or adversarial post-process to achieve fairness, and data centered on change or modify data, learn a fair representation of the data. Issues are, looks almost impossible to have a universal definition of fairness. This is a very important aspect coming into the picture when you look for AI itself, and different possibilities are demographic parity, equalized odds, equalized calibration. All the above are mutually exclusive. And so, for example, if you say the correct offender management profiling on alternative sections, Probelica concluded more blacks incorrectly predicted to be recidivate kind of thing. So now that is where this same thing holds, whether in US or in India, the same thing is going to happen. It says blacks face higher false positive rates, hence violate equalized odds. And non-points defense scores satisfy calibration. We cannot have both kind of a thing. The subtle challenges are, looks impossible to have one universal definition of fairness, lack of our understanding as to which groups are being treated unfairly, dynamics of fairness, impoverished data, and causal inference. In fact, this is what is happening in the India in many of the decisions that are coming into the picture or the other. The impossibility theorem is, if an instrument satisfies predictive parity, but the prevalence between groups differ, the instrument that achieves equal false positive rates and equal false negative rates across those groups differ. So navigating, how do we trade off different measures of group fairness, between group fairness and individual fairness, and between fairness and utility, you have a large problem. Given a large number of labeled examples from a population, learn a classifier that is accurate on a large fraction, let us say greater than 90%, recognize if an image has a bicycle, from a resume predict whether he will get an interview call, predict if a criminal will recidivate kind of a thing or the other. Now you can say what is fair classification given a large number of labeled examples from a population, a protected group, let us say X, learn a classifier that is accurate on a large fraction that is also fair with respect to X. So now the question would be, how do you define the notion of fair? Requires some independence with respect to the sensitive attribute. demographic parity, equalized odds, equalized calibration. So these are all, as I said, mutually exclusive, and you have a history. I will not go into some of those things or the other. The reasons for bias in the models: impoverished data or imbalanced data, labeled data is noisy and incorrect, measurement choice or measurement problem, and the model is the ML prediction errors, compound injustices, and human decision making are there. In the context of human decision making, tensions exist between prediction, and it does not depend on who is going to be the prediction. Sometimes in non-obvious ways, for example, police searching for a vehicle can be seen as a prediction of the presence of a contraband. If police stops, then you say something you may have done wrong and you may have a contraband under it. So inherent limitations, to conclude in some sense, limitations of AI fairness: lack of ground truth, categorization groups, need for sensitive data, no universal fairness definition, blind spots, lack of portability, limited power over the full decision open to abuse, and some more points have been discussed in the recent communications of ACM, kind of a thing or the other. And so now here, if you say to discuss mindless model fitting, none of this is remotely how humans think. Imitation approach has not worked well in the past. For example, airplanes, chess, Go, etc. Machines' advantages lies precisely in ability to crunch data. We have little idea at an operational level how humans think. So now here, in the human level concept learning, that's where the creativity comes into the picture. For most interesting kinds of natural and man-made categories, people can learn a new concept from just one or a handful of examples, whereas standard algorithms in machine learning require tens or hundreds of examples to perform similarity. So now here, if you look at, for example, people may only need to see one example of a novel two-wheeled vehicle in order to grasp the boundaries of the new concept. Even children can make meaningful generalizations by a one-shot learning kind of a thing. You see that there are various bicycles with only one wheel kind of a thing or the other, like in our Puranas, the Surya runs with only one wheel with a 5 horses kind of a thing or the other. You can imagine what is the thing that comes into the picture or the other. Human concept learning, people learn richer representations than machines do, even for simple concepts, using them for creating new examples. New examples, parsing it into parts relation, creating new abstract categories based on existing categories. In contrast, the best machine classifiers do not perform these additional functions, which are rarely studied and usually require specialized algorithms. So central challenges: explain aspects of human level concept learning. How do people learn new concepts from just one or few examples? How do people learn such abstract, rich and flexible representation? And even greater challenge arises when putting them together. How can learning succeed from such sparse data and also produce such rich representations or the other? To conclude, machines can provably learn whole concepts of concepts that can be characterized. Classes of concepts are appropriate and non-trivial for general purpose knowledge. Computational process by which machines deduce the desired programs requires a feasible number of steps. In the classic computing, polynomial is the one which is considered to be reasonable kind of a trend. Looking at the world via complicated, inexact descriptions, a new frontier for science and maths, machine learning, best hope for figuring out how humans think. And conclude, challenges for societal application need precise definitions of fairness goals and other goals. Precisely define what we want to solve, arrive at various provable guarantees of approximations if there is no deterministic or efficient solution. Real challenge is how to make algorithm decision support system support human values kind of a thing or the other. With that, I stop, and then if you have any comments and questions, feel free. Any questions or comments? Yeah, go on. Yeah, somebody could give a speaker. Mike.
Sir, as you know that the real-time problems are non-linear most of the time. How to solve these kind of problems where we do not have, if we talk about the linear regression, then we have only two coordinates. So if we have a complex problem, complex non-linear problems, so how we can solve it in a regression way?
See, like one of the examples what I showed you, which had 20 million variables, which was non-linear, and then, but many of those are aligned with one another. So now if you have chosen the right attribute, so it essentially becomes non-linear with respect to only some variables, but linear with respect to that. So the dimensionality reduction comes into the picture, and that's how the classic gradient descent method works.
Sir, in that case, that explainable AI, so would you suggest to use these kind of methods? So
No, explainable AI is something which is not confined to one discipline. Like if you explain in one form for a computer science, like a polynomial complexity is good enough, it may not be understandable by another chemist kind of a thing or the other. Explainability is one size does not fit all, and so you should have different this one, so that is a union of many of those technology and many people coming into the picture becomes essential if XAI or explainable AI has to succeed, otherwise it won't succeed. And like you had a long gap after the earlier artificial intelligence, which was re-energized in 2012, and nearly 40 years. And then again, if you don't see any fundamental results except for using the chatbot kind of a thing, again, you have a 10 years kind of a thing. But already you know that what are the problems of this one. So now if you go back, you say that there is a undecidable problem. Whatever you give, it will not be possible to solve that. And that is where the line comes into the picture. So you should have a clear view of what it is, what you are doing, and that's where a clear notion becomes very important.
Sir, then if we talk about the clustering, so before we go for the clustering, then we can perform some dimensionality reduction process. But if we talk about the deep learning, then till now, as per my knowledge, with respect to explainability, then for the deep learning algorithms, the explainable AI is not that much advanced till now. But in that case, would you suggest that we can, as you said, that union of various feature selection techniques? So would it help?
Now, in a deep learning, if you see it's a black box, you don't know why it arrived at that solution. Okay, that is the problem. So now people are trying to say, can I have something like a interpretable learning versus deep learning, so that at least for some domain this could be interpreted, and now I would say that this is the reason why this one is working, and that's how the reverse engineering has become a big problem in the context of deep learning or the other. It gives this result, I don't know whether it is correct or not, and that's where you have the fairness bias also coming into the picture, because it has different definitions of the fairness. Under what conditions you would call it as fair, and all this taken into account, you have to really focus on smart things and then do that. For example, suppose you take Ramayana. Suppose Rama is Purushottama. He always does good things and you have to learn from him. Can I build a AI machine which would only show that under many of the confusions what people have, I don't have confusions, so people have to say that whether he is always doing under the notion of the dharma that exists kind of a thing. So that becomes a real challenge at some point, Arvind.
Thank you so much, sir.
Yeah.
Thank you.
You had some question? Yeah, go ahead.
Thank you for the wonderful session that you just had. I have but a simple question. During your keynote address, I noticed that you mentioned Turing test. So my question is, how long do you think till the AI model catches up with the Turing test?